Hello, everyone. I have a microphone, yeah, but I can also do that. Anyway, so super happy to open this stage here today. I'm Arsenii Petrovich, but you probably know me as a guy in a spacesuit. So I'm the field CTO at Protofire, which is the company stands behind the Glif Node hosting. We are having a team of 3 wonderful, beautiful engineers. So it's me and Maria and Aleix who are working with me. As I was mentioning already to David, the most complicated part of this presentation was to make Aleix contribute his photo to the presentation because, yeah, he is not the guy who likes photographing. I'm here to present you essentially the Glif nodes, our activities like current, past, present, and our metrics that we are having, our future plans, and more and more and more. Since there are that many of you, feel free. There are maybe you could each of one of you could take the microphone already and just start talking and interrupting me if you want to, just simply because, I mean, who cares? I'll probably give the one, okay, so...
Testing. Yeah, so we might have more people wander in. I think they're still at lunch, maybe. So
yeah, I mean, if the more people are going to join, so maybe I will just then be a bit more in the presentation mode. But for now, we could just keep it as a friendly, as a friendly chat, I would say. Yeah. So, especially considering we all know that there are challenges when running the Filecoin nodes, especially when we are talking about the growing needs for the RAM, for the SSD drives, for the... No, it doesn't work that way. Okay. For the RAM, for the SSD drives, and so on and so forth. But the one interesting thing that I actually learned from this conference, which was not the part of the presentation, but the one thing that I want to note and want to share with all of you here, is that the thing that we are missing from time to time when we are talking about the requirements is the bandwidth. And given the fact that the IPC is the super hot topic nowadays, and there is going to be more and more sub-networks, right? We will have to be very careful further on, like when we are talking about the hosting of these IPC subnets, when talking about the bandwidth and about the traffic that we are passing. Because okay, for example, the archival nodes of Lotus is 40 terabytes right now. But then imagine that somebody is retrieving this data of 40 terabytes. So we're having the 40 terabytes of data, which is okay. But then we need to pass that 40 terabytes of data. And then these 40 terabytes of data are starting multiplying by the number of users who are receiving this data. And that becomes even a bigger problem than, so bandwidth becomes a bigger problem than the disk or the RAM or something else. But yeah, that's a side note. First of all, let me quickly touch upon, because that's something that confuses a lot of people about the structure of the Glif. So the Glif actually consists of 2 companies, which is Protofire and Infinite Scroll. So if you guys ever met the guy named Jonathan Schwartz, he is the, I think, CEO of the Infinite Scroll, while I am the lead, the CTO of the Protofire. So we are having a branding partnership name that is called Glif. And together we are working on different tools in the Filecoin ecosystem, despite the fact we are, even though we are responsible on different areas of the ecosystem. He is more on the application side, but not completely, more of like wallet, multi-sig, notary, infinity pool. And we are doing the APIs, api.node.glyph.io and all that you know, CAD checker that I'm going to cover as well today. And all these public repositories like Filecoin IAC, Filecoin Docker, Docker images, that's one that are like the most popular nowadays, and so on and so forth. Cool. So, in Protofire, we are trying to, and I will explain a bit later why I'm even talking about that. In Protofire, we are trying to adhere to the following principles. The first one is where no man has gone before, meaning like that's despite the fact like our team is currently mostly consist of DevOps, we are not sticking to this name of DevOps. We are more of like explorers who are seeking to build a better solutions and push beyond our comfort zones. And like our name, this DevOps name is not really defining us. We are keep evolving. The second one is keep a little fire burning. The thing is like we are in the very harsh bear market nowadays, and what we are trying to do, we are trying to nurture and protect all the projects we are currently working with, since we are like a DAO that is not focused on only like a financial gain, but rather on building a strong community, strong DAO, while probably maintain just at least a healthy PNL. We deeply care about the success of every project, and yeah, we are trying to survive through all this crypto winter, right? The third one is the only way to do great work is to love what you do. Well, that's kind of self-explanatory. Let's talk about the services that we provide nowadays. Nowadays, we provide the hosted nodes, and the hosted node can be categorized to many different like subcategories, right? The one categorization we could have is the networks, obviously, like mainnet, calibnet, and spacenet. The spacenet is the network that was created for the IPC testing specifically. It's marked with the different colors, right, because it was deprecated and no longer in use, right? Also, we have been participating in other networks like, I don't know, like the hyperspace net, like the Wallaby, right? Like the butterfly net as well, if I recall correctly, and more and so on and so forth. From the nodes, from the reservation perspective, the nodes can be distributed to like categorized to public, private, and dedicated. So public is self-explanatory. That's one that you have API node.glyph.io. That's everybody is using nowadays. The private is the nodes that we are currently. The process works the following way. So if you need the private node that for some reason maybe you need some specific configuration, or the bandwidth is not enough, or like whatever the reason there is, whatever the reason you have to apply through the Google form that you can find either at our website or at our Slack channels, and then the the Filecoin community representative goes and validates whether we as a Glif node should be dedicating the node to this third-party provider. However, this process is going to be changing, and I'm going to talk a bit about it a bit more in the next slides. And the dedicated nodes. The difference between private and dedicated is only in the fact that dedicated are also private, obviously, but dedicated node is private node that you do not share with anybody else. You might need dedicated nodes only in like rare occasions if you need like sign or admin access level to the node for some very specific reason, or maybe you need like a dedicated channel, dedicated connection to this node for some reason. From the history perspective, there are three categories right now. The recent state, the nodes that are recent state is like 2,000 blocks guaranteed. We have to set this limitation for the very important reason, because if we keep the nodes for more than 2,000 blocks, the node starting to get less healthy, less responsive. So from time to time, we have to like manually kill the node in the recent state pack and restart it from the latest snapshot to make sure that it's going to be like it is able to sustain the billion requests per month that we are receiving, almost billion. The FVM archival and the full archival are more of two types of archival nodes. The FVM archival is essentially the archival nodes that start from 14th of March 2023, when the FVM was started, and contains all the FVM data. The full archival contains full data, which is 40 terabytes nowadays. Moving on. Yes. We have the open source repositories that are, the left one is kind of popular nowadays. The other two are not that much, as we use them for running the infrastructure that we are having. The left one is the Docker images that we publish with at the very same time as the Lotus official team is doing that. So essentially, since we started to publish the Docker images before the official Lotus team started to do that, our Docker images are nowadays the most popular, and that's kind of yeah, a funny side note. For the Filecoin chart and Filecoin IC, it's essentially the Docker Helm charts that allows you to deploy the Docker images to the Kubernetes, and Filecoin EIC is essentially the code that will allow you to deploy the Kubernetes to the AWS cloud. Yes, and also the one repository that I'm not mentioning is the Genesis Arc. I was presenting it yesterday, so please, like I think the majority of you attended the presentation, but for those of you who are going to be viewing that on YouTube, just go and watch another video. It's a really cool project. So that's not yet published. But hopefully gonna be. CAD checker. Did any one of you use that tool before? No? No. Okay. So this is the tool that we host. It's available under the cad.filecoin.tools or under the filecoin.tools. It provides the possibility to verify, to check the status of CID, the content identifier, inside of the Filecoin network. So essentially, like CID is like, well, yeah, not going to go deep dive into that. You could use the CID checker to verify that data is safely stored on Filecoin and to find also the best deals for storing and retrieving data. CAD checker is also important because it actually provides the ZST archives of state market deals. So there is a method, API method, that is called state market deals. That's like simply like it returns a huge array. Huge JSON array of the market deals available. It's nowadays I think like I don't remember, something around 100 gigabytes inside, if I recall correctly. I might be mistaken though. So the CAD checker is, because of this method being so resource intensive, it is blocking on api.node.glif.io, because I mean like otherwise we would be like spending a lot on traffic at least. So to avoid that, we started to perform this operation internally, pack that to the ZST archive, and publish it online, so you could always get this download the ZST archive, which is compressed up to 90%, so it's around 10 gigabytes instead of 100 gigabytes. And with this ZST archive, you can unpack it and use it for. You can unpack it and use it for for market analysis. Yeah, even though it's not used by any of you, I know it's currently used in the CI/CD mechanism of Lotus development. So it is still important. The CID checker itself was deprecated, and it's gonna be like, at some point in time, there is going to be another major update on the network, and we will not be like updating the CID checker after that. But I think the one model that we will have to keep running, at least for some time, is this ZST compressed archives. Moving on. So, metrics. Yes, let's talk about the technical and business metrics of the services. First one, geographical distribution. Nowadays, we serving nearly billion requests per month, as I was saying, from at least 3,000 unique customers per hour. When I'm saying unique customers, I'm of course referring to unique IP addresses. So we were able to collect this data only for the couple of hours, and it was around 3,000 unique IP addresses per hour, which is kind of a lot. Most of our traffic comes to the public recent state mainnet nodes, which provides the latest information. And if you talk about the geographical distribution, then we will see a very interesting change. If you were attending like 1.5 years ago, one of the engineers working with me, his name is Vlad, he was presenting essentially the very same statistics. And back then, the leading country was actually China and Asia in general. Nowadays, it's the traffic shifting to the United States. Back then, 1.5 years ago, we decided to migrate our infrastructure specifically to Japan, just because of the geographical distribution. We wanted to be closer to our customers, but now it seems it was... Well, it was not a mistake back then, but it might be reasonable to migrate back. And we will talk a bit about like why we want to migrate again, make migration great again. But before, let's talk about the uptime. The uptime is great. I mean, like the infrastructure currently located on AWS, it's provide good uptime, and we are having the like at least 99.99 of uptime, which means that the downtime is less than 5 minutes per month, which is great. And in the last months, it was 0% of downtime at all. Sorry, did I? Yes, I missed one slide. The top methods that being requested, by the way. The top one is chain head, the second one state miner power, the next one chain get message, and it gives a very good understanding. And the ETH methods, by the way, are also in the top, which gives a very good understanding of the use cases that users are. How the users are using the network, right? So the chain head is not that much of an interest. The state miner power is, however, like more of interested. This method returns the likelihood that the storage miner will be elected to mine a block, which means that a lot of people are interested in the mining activities nowadays, right? Then storage, state market storage deal about the deals. So the network is kind of like having a lot of popularity in terms of like making deals and knowing about the mining activities, and that's great. What else? Dun, 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 dun. Yes, the important thing to understand is that we allow only read methods and ample push write method, which is a secure method because like when you're sending an ample push request, you're sending a write method, that's for sure, but you have to sign sign all the information before sending, so you're not sending any unsafe information to us, and that's how it's currently organized. Yeah. So, a short run on the tips of and tricks of like based on our experience of what we um, suggest when running the Filecoin nodes. Uh, yes. First of all, the instance architecture. If we're talking about the clouds, and even if we are not talking about the clouds, in these recent days, the one thing that becomes more and more popular is the ARM architecture. It's considered to be 30% more compute effective, and yet it is not as popular. So to attract the popularity, the majority of the providers are giving you discounts on the ARM instances. Glif.io started to publish the ARM Lotus image, so you can run the Lotus on top of the ARM architecture and keep saving money and boosting the performance, which is great. Second thing. Second thing is the rate limiting. Here is what we need to understand is that, yeah, I'm probably gonna skip that one. That's not of much interest. And yes, the Lotus cluster. The one thing that we started to get like some of the complaints from the users after we switched to the to the Lotus gateway is that from time to time our users are not getting the single view on the network. The reason behind that is I was mentioning that recent state nodes is essentially a cluster of nodes, right? So what you're doing, like you're requesting the chain head, and chain head responds, yes, I'm on the block 1 million. But who is responding to that? One of the nodes behind the cluster, right? Then you're asking for the very same question, where I am on the chain head right now, and you get the answer. Now you're on 1,000,001 block, which is the different information from what you were getting before. Why is that? Because the reason for that is that another node is already somewhere like 1 block ahead in the network. But then you're requesting the chain head again, you're getting to the previous node, and you're getting the block number 1 million again. And that becomes a problem because sometimes you're getting information that your transaction have already passed, but then you're getting the information the transaction is not passed yet already. It didn't pass yet. And that is a problem because users can't really rely on the information they are getting. So how to solve that? Actually, we are working with the Lotus team on the on helping on implementing thing called Lotus cluster, which is going to be using Yugabyte DB. And this Lotus cluster and Yugabyte DB will be used like as a shared database and the shared view of the network. So there is going to be like, essentially it's going to be like the Lotus will be like modeled to several components. One of them is going to be an indexer populating the database, and there is going to be several RPC nodes that are serving the information from the database. We hope that we are going to be introducing these features soon to solve the issue we're having now. Now, if you haven't seen the like if you're still willing to run the Filecoin nodes in cloud, which might be not the best idea in the modern days. You might still want to look for the presentation that we, sorry, for the Medium, for the article on Medium that we have been writing, and yeah, and about like how to treat the nodes over 16 terabytes, because the majority of the clouds gives you the limit of 16 terabytes per disk, and since the Lotus node is 40 terabytes, right, you have to deal something, you have to do something about that. You can either use more expensive disk, which will be like 3 times more expensive, or you can use LVM arrays. And we wrote an article explaining how to do that and bringing like examples around how to do that. So about the future plans, what we are going to do, make the hosting node sustainable again. Here it's the last part. We are going to be like finishing, starting to like talk for a couple of more minutes we're having, right? The one thing that I want to explain is that nowadays the majority of our costs coming from the private nodes and from the dedicated archive nodes. While the majority of requests, around like 95% or something, is still going to the public nodes. So what we need to do first is to, since the majority of the costs are going for the private and dedicated nodes, is to start charging for those using these nodes, which sounds quite reasonable, right? But to achieve that, we need to do something rational. The majority of RPC providers, like for example Anchor, they have the free plan for you. But after that, if you're exceeding some number of RPC requests, they are starting to charge you. The problem here is that, do you think we could really compare the request that is the most popular chain hat versus the request that is, I don't know, chain get block messages, especially if we go by deep into the history? Is it like the same from compute effectiveness? Yes, not really close even. I mean, like, I think that's the way that it is done now is far from being reasonable or being like rational. So what we want to do is we want to start patching the Lotus gateway to add there the measurement and compute units that are going to be measuring the complexity of this request. However, this is the place where we will need a lot of input from the Filecoin, from the Lotus core team, to understand how to what would be the best way to achieve this efficiency. And of course, the another thing that we need to do is to understand that despite the fact that cloud brings a lot of stability and a lot of efficiency, given the growing requirements for the nodes, we will have to be migrating to the bare metal instances. That's one thing that I was talking to at the very beginning, saying like, okay, we migrated to Japan. That was a good decision. Now we want to migrate again. Now it's going to be migration to the States back to be closer to customers again from one point of view. But from another point of view, it is going to be the migration to the bare metal instances to make the instances cheaper. And the third thing, to make the infrastructure cheaper, since a lot of costs go to running of the archival nodes, is actually switching to alternative blockchain clients like Forest, for example. It might make a lot of sense given the efficiency of the database that you have achieved. So that's pretty much it. Sorry for being so boring. So thank you for your attention. I'm super open to any questions or anything. You could just ask, yes.
Your archival nodes, are they publicly available, or how does one
No,
access them?
the archival nodes are private. They're dedicated. They're not dedicated. They're private. So if you go to where they are, to this distribution, yes, I would say that we have the mainnet archival node, which is private, and the CalibNet archival node, which is also private. For CalibNet, it's honestly it's not of a big problem. The CalibNet is very small and very cheap, so I wouldn't even consider that. We can even publish that if it's needed for someone. As for the mainnet, that's more of a big problem, because when we are giving the nodes to the people, we are realizing that they are sending the request that making this node to suffer and fall behind the chain. So the private mainnet archive nodes is really expensive. I even have the calculations here. Give me a second. I have even a breakdown which shows which answered the question on what is the average price of one request per type of the node, I would say. Requests, yes. So if we are talking about the nodes, the average cost of one request to the publicly available nodes is 0.00004, which is good. When we are talking about the CalibNet, the average is 0.00001, also good. But when we are talking about the archival nodes, the one request might cost up to several hundreds of dollars. If we are talking about the infrastructure costs versus the number of requests we get versus the complexity of this request. And just imagine 0.40.1 versus several $100s.
So with Forest, we don't support all of those APIs, but we would love to work with you to see where we can fit in and if we can make this cheaper. I think we do have a comparative advantage when it comes to the full node. And we would love to be able to provide at least some of those API calls for the full node, and doing it as cheaply as possible.
Yeah, that will be lovely. We are totally open for that. I can definitely share the presentation with you, so you and all the other statistics, so you could check what are the methods we are most likely gaining, and what are the most used by our users.
So I'm a total noob on this stuff. I'm the storage guy for Web3 Mine.
Okay.
And I sat back and I watched us spinning up new nodes, and I was impressed, I guess I should say, that we were going to find, we were looking for people who had a copy of the latest chain to begin to sync with. So given that, what I hope to learn here is well, the obvious question came to my head is, why isn't there a CID out there on IPFS, on some pinned IPFS surface, with which I can cascade chained link of CIDs with which I could reconstruct up to within the last 2 weeks of where the state of the chain is, and then sync up with the Lotus node that's running the software. Maybe I'm asking entirely the wrong question, but I saw, or a question that is irrelevant, but something as critical as the master full copy of the blockchain, I didn't see a deterministic process to recreate that from scratch, and a neighborhood of friends that, or other nodes that you're happening running and whatnot. How would, if I go back to Colorado tonight and I wanted to set up a public mirror that others could pull from, or I wanted to set up a process by which I chunked the existing chain in full into 32 gig into car files and then onboard that as a linked list of CIDs. Is something like that possible? Is that something? How, if I go back to Colorado and I wanted to host a full copy of the chain that was always within 2 weeks of being the most recent copy and make it freely available, how would I do that?
Of the latest 2 weeks specifically, right?
What's that?
Of the latest 2 weeks specifically, you're saying?
Yeah, within 2 weeks.
Yeah, I mean, like, the thing is, I know that if you're talking about the publicly available information, right, then we would get the public snapshots only from 2 days. 2 days, I think, 2,000 blocks, right? 2,000 tip sets. Slightly, okay, so slightly less than 1 day of the history. And I don't think you will be able to spin up immediately for something for 2 weeks back. Despite the fact that
Divorce the time periods I'm looking at. What I'm looking for a way to, from what I understand, to iteratively make some kind of request to reconstruct the chain on my end would take a very long time, which is why everybody starts with a copy of a copy that somebody had, like what I saw my team doing, looking for somebody who had a copy that was fairly recent. So we had a node in one of our test labs, and it was 3 months behind because that stuff was reworked. That was older, and so we found a copy of a copy from a friend, started with that, and then started Lotus Sync from that. Lotus Sync, I understand, is very, very slow. And I looked at this, and again, I'm the storage guy. I'm not the crypto guy or the chain guy. How, if I wanted to set up even within our own organization, a source of truth that was always within 48 hours or 2 weeks or something like that, and I'm hosting it on ZFS, I snapshot on a regular basis, and I spin up a new node. I do a ZFS send to the file system that was a snapshot of the most recent thing, send it over there, start Lotus Sync, and boom, everybody's happy within 4 or 5 hours. But I have no idea where to start with that copy of the chain that includes the Genesis block.
well, essentially, from what we know, right, is that these snapshots that you're getting, like, and that we are getting, that we are relying on, they one way or another have enough information to verify that the current state that we are having of the network is valid, and it's like can be mathematically proven, right? So, but other than that, there are teams, including the Lotus core team, including us, including, I think, many other guys who are hosting the full like history of the blockchain since the very first blocks. Not sure if that answers your question, though.
It is. So it's kind of astonishing to me that something as critical as the keys to the Magic Kingdom, that is the immutable source of truth for time and eternity, for all things Filecoin related, that it's hard to go back to the Genesis block and reconstruct the whole thing.
So,
Especially when we claim to have a tier 4 archiving service that is going to be persistent storage forever, and so, or at least 18-month contracts. So I was kind of thinking that there would be a root level CID that would take you into a chain of history so that I could always reconstruct the full chain from the Genesis blocks with nothing more than IPFS request from, if that doesn't exist, it'd be a good exercise for me to try to create it, because it seems like it should be.
you're definitely
In fact,
asking
I'm going to
this.
S3 buckets.
You're definitely asking this in the right room. So the three of us all share the same pain, and it's something that's being actively worked on by all three of our teams.
Okay.
The fundamental issue is that that data isn't available on the network through BitSwap or GraphSync or whatever. I mean, if you expose a full archival node, that's just one source that you're drawing it from. So trying to sync the whole chain since Genesis is going to take forever if it's even possible to secure a full archival node for that long.
Right.
So ChainSafe guys are working on a sort of a solution for this by exporting like the full chain history in archival snapshots, right? So you would be in theory able to reconstruct from Genesis that way, but that would be like out of band, right? David, did you want to?
Yeah, I think it's very interesting that you bring this up, and I'll be talking about it in my talk. like this exact problem, because like we had the same issue because the data is just not available, and it should be available.
Okay, so we could probably give you like a word.
Can I ask a
yeah,
couple of
sure.
questions first? Yeah. So for the model that you told us about, where you're hosting multiple Lotus nodes behind gateway, so you're basically doing like a reverse proxy model, right? So
Yeah.
yeah. I think the example you meant to give was like you make a first request and it says chain head is at 100, and the second request you make later says 99, right? Because then that would suggest you're going backwards, and that doesn't make sense,
exactly,
right?
Exactly. That's
But we got what you mean. But the thing is that is actually like correct, right? Because it's a distributed system, so different actors will be at different heights.
That's
right?
good when we are talking about like the system in general, but when we are talking about the RPC provider, you expect the RPC provider to return consistent data.
Yeah, but it's I don't want to say it's a philosophical question, but you'd expect a client of such an RPC request to be aware that there could be discrepancy, right? Because that discrepancy is important. I'm not saying that behavior is ideal, but I'm saying that answering with like a ratio of how many nodes have reached that height might be an intelligent answer as well, right? You could say that, we're running 100 of these nodes and only 50 of them have reached this chain height. So that also gives you like a micro sample of what the rest of the network might look like.
Well, it's literally a chicken and egg problem. I mean, like whether it's we who should be providing the consistent data or the client who should be expecting the discrepancy.
Yeah, okay, yeah, that's fine. But actually, the answer I was trying to get to, the question I was trying to get to, is you were thinking of replacing this with a Yugabyte database backed solution. So from my understanding, you're just basically having one writer and multiple readers. So there's only one state that you're
You're talking about what if this one writer is going to get their own data?
Or you have a corrupt state somehow. So which nodes get corrupt, right?
Yeah, of course, that's super reasonable. As for the corrupt state, I wouldn't be so worried about, simply because we have like, as we have the public cluster, we have the private cluster, and one way or another, if public cluster go bad for some reason, we can always super fast recover from the private cluster, simply like copy. And that's not of a big problem. As for the writer problem, I can agree that this exists, even though this feature is not production ready yet. And this is one of the questions that I would be definitely raising when it's going to be more, at least go from alpha to beta, because for now it's just something we started to work on. And I can definitely agree that having one indexer might be tricky.
Yeah, that's fair enough. And I have one other question, and this is probably going to be a simple no. Have you done any correlation between your client IPs for RPC requests and checked what set of methods they're calling? So you were earlier you were quoting individual methods, and you're saying, okay, this is probably coming from storage providers and such. But like, have you said this client IP is making these 6 RPC request types and in these ratios? Have you got any information on that?
I feel a bit so the one thing that we are still contributing here in the blockchain ecosystem is anonymity, right? So yes, we definitely gather some of the statistical data, but that thing sounds a bit more of like already like a profiling, which might be useful in some cases, but it's kind of like, I'm not sure it's the super right thing to do, so we have never done this before, and not sure that we ever will be.
That's basically the conclusion we arrived at as well. But yeah, it also puts you in a bit of operational difficulty because you have this, you don't know how to change your systems to better accommodate
To better serve the client's
Exactly,
needs.
yeah.
Exactly, yeah. So from one point of view, I need this data. From another point of view, I mean, like, I don't want to the blockchain community to tell me, oh, you're a bad guy because you're, analyzing us.
Yeah, but if you have that data, you could anonymize it first and then do analysis, right? Then I know it's sort of a middle ground and it might be seen still as like, data mining, but
Yeah, I mean, like, that's a good idea. But for that thing, I would definitely want to migrate to the on-premise first, because the tricky thing here is like our current way of storing things. We are getting 1 billion of requests per month that we will have to analyze. And Open Search is literally struggling with that amount of data. We tried to at least start to get at least to start filtering things, right? And that was problematic. We will have to have something really, really big for analytics. And for that, we'll have to have our own servers, I would prefer.
perfect. That's all I had for you. Thank you so much for your talk.
Sure, super happy.
Oh, I have one question. For the recent state nodes, you said that you were restarting them, I think, to get better performance. Can you tell about why? Why are you restarting them? Can you just keep them running forever?
No, you can't. So the tricky thing here is that when the node is getting more and more data, it's starting to perform worse. Recently, there was, not recently, several months ago, there was a feature that was introduced in the beta stage or something like that, that's supposed to I forgot the name of the feature, unfortunately.
This is the split store.
Yes, this one. That's supposed to fix the problem, but practically speaking, the restart of the node make the node work still better than even with this feature, just like that. So I mean, even despite the fact that yes, the split store made the situation better, we are still restarting the node just because it's even more better.
As I understand it, it's a way of dividing the hot data and the cold data,
Yeah.
such that all the things that you don't actually need, they don't slow down the database.
On the sector store, I have to, there's two things I have to do: large sequential writes and as high speed as possible random reads, 16K random reads, 160K of random data pulled out per sector to do a post, whatever you want to do. On the cache files, I need to make those widely accessible for whatever the GPU thing is. And there's another FIPS that we're going to be pushing through that will allow the further disaggregation so that the storage worker only has to retrieve the proof data and hand it to centralized GPU so that I can have huge 10, 20 petabyte storage arrays, but I don't have to have my precious GPU resources spread all over the place. I just take collect all the proof data from a Filecoin partition, which amounts to 384 megabytes in totality, and send that to the centralized GPU thing, and I can cost reduce the crap out of my storage servers while keeping my expensive compute resources centralized. That little squirt of 384 megs, who cares? But it takes a whole lot of screwing around to get that data from a collection of 900 disks. So how did that improve the performance here? How did the split store affect your life?
That's the thing. I mean, we expected that it would be a magical button that will solve all the all the problems, right? But it did not in the end of the day. The split store supposed to do the thing that you were talking about, to split what is going to be hot, what is going to be cold, right? So the hot data is the recent state data, and the cold data is the older data, and all that kind of stuff. But at the end of the day, we realized that if we simply restart the node from the latest snapshot, it just works better, practically speaking.
And again, this has been my first experience watching somebody spinning up a full Lotus node, and there was so many things. There was swap file and virtual memory management, environmental flags. We were sitting there watching the Lotus storage miner going and going and going, and its memory footprint was moving into the swap file. Now we're talking about a machine that had a 0.5 terabyte of RAM. There was no, and it wasn't fully operational online. It was just sitting there, twiddling its thumbs, and I'm watching the VMM footprint grow. So something is broken there, and that's got nothing to do. So the fact that we have split store, now we've got the opportunity to optimize storage I/O paths through there, which you have to have a storage guy that actually does that. But the other thing is that I'm seeing what appears to be the static allocation of structures and the reference counting, the garbage collector, never has a chance to go back and clean up, and that stuff starts laying around in Crofton and moving into the swap file. And I'm seeing that all the way through the latest flavors of Lotus, which again, just restarting it, the VMM memory manager has a chance to reset and not lose his mind anymore, trying to keep track of all these little things. And I can't imagine it's actually doing useful work. I mean, it was sitting there quiesced.
The garbage collector is, by the way, interesting topic that you touched upon. So the 40 terabytes, it's actually like there was a period of time when there was like a bug in the client that was causing the chain state to grow 3 or 4 times faster, and we still didn't get rid of this data because it's still backed into the whole BagerDB stuff. And that's a good question probably to you, David, right? David, did you, like, in the forest implementation, did you, like, garbage collected this?
So we do have a very aggressive garbage collector that we feel works better than split store. But there's a lot of data that just cannot be deleted. Some of the junk data that was generated accidentally, that is just part of the.
A garbage collector can't save you if reference counts don't go to 0.
I mean, this might be a really stupid and obvious question, but have you opened an issue with Lotus about this?
I haven't. I just saw it. So again, I'm the storage guy. I come from Seagate, and I'm watching. I'm looking and learning and how the Lotus stack comes together, and I'm watching this stuff going. I'm going. As an old C coder, I would be fired.
Yeah, I understand that. But like, that's excellent feedback for the Lotus team.
Yeah.
So like, if you can get it into an issue, then we can look at.
Well, I got
that.
the split store stuff pushed through about 6-7 months ago. I think it was there about that time. Now there's another optimization to disaggregate the proof worker from the proof storage, but that's got nothing to do with basic runtime functionality.
Yeah, thank you very much. Thank you for opening this track.
Thank you.